Welcome to another back of the net recording. This one's called the Crammer. This is for you to watch just before the exam, maybe the weekend before, the night before, if you can get up early enough, the morning before. This is just to give you those last minute tips, those reminders, the last minute reminders for getting a grade C. Okay, here we go. First of all, knowing these keywords about number: multiple, factor, prime, square, cube, and square root. People often confuse the multiple with the factor. Always remember the multiple of a number has to be more than the number. Factor of a number will be fewer than the number, will be less than, not really fewer, but less than does. Prime numbers, exactly two factors, often say they can only be divided by themselves and 1. A square number is a number times by itself. We normally say an integer, and the integer is a proper name for a whole number, and it's multiplied by itself. A cube number is a square number that's then again multiplied by the original number again. Not a square number squared, but the original number times a square number. For example, 5 times 5 is 25, so 25 is a square number. If I times 25 by 5 again, I'll end up with a cube number, 125. The square root of a number is a number that gives you the number squared that gives you the number. So for example, what gives you 64? 8 times 8. So the square root of 64 is 8. This here might be a typical question. Question 1, a factor of 24. So which one of these numbers here is a factor of 24? If we're looking along there quickly, 3 is a factor of 24, and so is 8, because 3 times 8 is 24. So I've highlighted those. Question 2, a multiple of 9. So it's going to be something in the 9's times table. It's got to be more than 9 because it's a multiple is more. 45. Could also have 27. Could also have 81. A prime number. Well, all of these aren't prime, apart from 3, so that's another chance there for a prime number. So we can have a prime number there. 13 is also a prime number because you can't divide 13 by anything other than 13 and 1. Square number, we just talked about that. 9 times 9 is 18, so 18 is a square number. 4 times 4 is 16, so 16 is also a square number. The square root of 9. What times by itself will give you 9? The answer there, of course, is 3, because 3 times 3 is 9, so the square root of 9 is 3. 3 cubed, that's going to be 3 times 3 times 3. 3 times 3 is 9 times 3, 27. Question answered. Now some of these here have got more than one dot. That's absolutely fine, and in the exam when you get this type of question, when it's pick out the rectangle, which ones can you pick that are a factor of 24, a multiple of 9, it doesn't matter if you select them more than once from that same grid. Okay, next topic. Product of prime factors, PPFT, draw the factor tree. Okay, so the first question, express 24 as a product of its prime factors. Write 24. I can split that into 12 and 2. 2 is a prime number, so I circle it. That's 2 and 6. 2 is a prime number, so I circle it. That's 2 and 3. They're both prime, so I circle it. I've then got 2 times 2 times 3 times 2. We normally write them in ascending order. Job done. Written there as a product of its prime factors. Second bit, find the highest common factor of 40 and 48. 40 and 48. What number can I do that goes into both? Looking at that very quickly, to me, it's obvious that that's going to be 4. So I write a 4 there. 4 times 10 gives me 40. 4, what times what gives me 48? The answer is 12. I then see if I can split that down again. I'll do it in a different colour. What can go into 10 and 12? Looking at those, 2 can go into both of those. That would be 5 times, and that would be 6 times. Can I now find a number that goes into both of those? No, I can't, so I'm stuck. Got to stop there. My highest common factor will be the vertical bit, which is this bit down here. So my highest common factor is going to be 4. Highest common factor is going to be 4 times 2, which is 8. I haven't asked you this time what the lowest common multiple is, but you may well get asked the lowest common multiple, and that is the L shape. So it's down there and across there, the last line you had there. So that'd be 4 times 2. So the lowest common multiple would be 4 times 2 times 5 times 6. Well, 5 times 6 is 30. 30 times 4 is 120. 120 doubled would be 240. Important to know those. I like this method here where you've got your L being the lowest common multiple. Remember the H is like the sticky up bit of the letter H. Okay, next topic. Percentage increase of and percentage decrease, and also percentage of an amount. Okay, we very often see this question. Find a percent of an amount. We always use the same method here, and this is where we write down 100%, 50%, 25%, 10%, 5, and 1. And then I'm going to write down what those amounts actually are from the amount in the question. 312. I can halve that for 50%, which is 156. I'm doing this quite quickly. You wouldn't be doing it this quickly in the exam. You'd be thinking more carefully to make sure your halving was right. For the 10%, I'm just going to divide it by 10. Don't forget to put the pence in there, the actual pence. Then this one will be 15.6 or £15.60. And finally, £3.12. I've then got to work out how I get my 27 there. So I'm going to make up 27 from a 25 and 2 ones. That will give me, sorry about that, that will give me 27%. I now write down what those amounts are. So 25% was £78, and then 1% was £3.12, another £3.12. Add those up, that's £24. That's 24 pence. That's £84. So £84.24. Put that in. I shouldn't be doing a double dots there. That's a bad habit. Don't forget in the exam 84 1 dot 24. Question done. If I was going to increase by 27%, I would add that on to the original amount. If it was a decrease, I would of course be subtracting it or taking it off from the original amount. Estimate the calculation. I love this question. I always think it's quite straightforward. You have to have learnt this bit here. That if you end up with dividing by 0.5, it's the same as timesing by 2. If you divide by 0.2, it's the same as timesing by 5. And if you divide by 0.1, it's the same as timesing by 10. You have to learn that before you go in the exam. Then it's very straightforward. When we're estimating, and here's a question here, this calculation, we always go to one significant figure for each of the numbers in question. So 53 is nearest to 50. 91 will be nearest to 90. They're being times, and 22 is nearest to 20. It's approximately that. So 50 times 90 is 45, and the 2 zeros, divided by 20, and that's going to be equal to 450 divided by 2, and 450 divided by 2 is 225, and that's my estimate. 4 rules of fractions. Always causes problems for loads of students. Let's make sure it doesn't happen to you. Multiply is the easiest. Your times are tops and your times are bottoms. I've got an example here. So 3/4 times 4/5. The answer to that is going to be 3 times 4 is 12, divided by 4 times 5 is 20. That's my first answer, and I would always write that answer, but I can now simplify that to being 6/10. I can simplify that to being 3/5, so the answer is 3/5. But show that progression right the way across. The second one, Divide is the next easiest, and remember KFC. Sharing out, sharing is dividing, sharing out your KFC bucket. However, we use the KFC for keep it, flip it, change it. So I'm going to rewrite this question here as keep it, 2/7, change it, the second one, 8/1, and change the sign from a divide to a times. And now I've got a times question that was the same as this one here in effect. So 2 times 8, 16, 7 times 1 is 7. I can't do any cancelling there, but I can say, how many 7s are there in 16? Well, 14 would be 2, and I have 2 left over, so it's 2 and 2/7 is my final answer. Okay, coming over to add or subtract. They're more difficult when it comes to fractions. If you know what you're doing with a common denominator, stick with your method for that. If you're used to the upside down picnic table, go for that one as well. And that's the one I'm going to show you now quickly, the upside down picnic table. We draw it upside down, just like that. We did 1 times 3, then we did 4 times 2, so it's plus 4 times 2, all divided by 4 times 3 is 12. So we did one diagonal, that's there, the other diagonal, that's there, and then the bottom is there. I'm now going to work that out. 1 times 3 is 3, 4 times 2 is 8, divided by 12, then 3 add 8 is 11, so it's 11/12. Final answer there. Another example here, I'll put a negative 1 and subtract 1 in there just to show it's exactly the same. We draw the picnic table, 1, 2, 3. The first one I did was 3 times 11, which is 33. The second one was 2 times 7, which is 14. 7 times 11 is 77. This time it was a subtract question, so I'll put my minus sign in there. 33 subtract 14 is going to be 19, so it's 19/77. You could try and see if you can cancel that, but I know 19 is a prime number, so I can't. That's fractions. I'm just going to do one more little bit on fractions, because today I've helped a few people and they're all struggling with this question. They wanted 3/8 of £40. The simplest way to do this is find 1/8. So 1/8 is basically divide it by 8. So 1/8 would be £5. 3/8 is going to be equal to £5 times by the 3, which equals £15. Just did that bit extra there, because a lot of people seem to be struggling with that today. Right, dividing in a given ratio. We've done this lots of times as well. Share 45 in the ratio 2 to 3 to 4. The key bit is the share word, and then we have the ratio, so we know it's one of these. We draw our grid first of all. We've got 2, 3, and 4. We need a total. When we add this up, 2 add 3 is 5, add 4 is 9. That's my total there. That's my parts. And my amount. Okay, I know my amount is £45. I've got to find my multiplier. 45 divided by 9 equals 5. So the multiplier is times 5. So 2 times 5 is 10. 3 times the 5, 15. 4 times the 5 is 20. 20, 30, 45. I know I've got it right. So I've now shared it in that correct ratio, 2 to 3 to 5. In the actual exam, of course, they'll be asking how many each part is down here. Don't forget to put units in. If you're asked what the pounds it is there. Okay, direct proportion and exchange rate problems. This is where we're going to use our flow diagram again. Read the question. When Raj went on his holidays, £50 was worth €80. That's the key fact. They're giving you the fact there. That's the fact bit of the question, that £50 is worth €80. Raj had £120 to change into euros when he went on his holidays. How many euros did he get? That bit is the question bit. Here we have it, the question. I now use my flow diagram to help me do that. So I know that I start with my pounds. It's from there. I'm going from 50. I've got to get down to £1, and then I'm going from £1 up to 80 euros. I've actually put the wrong sign now, I apologise for that. So 50, I'm going to divide by 50, and then I'm going to 1 to 80 is times 80. So my flow diagram is going to be pounds times, divide by 50 times by 80 will give me my euros. So I can now feed the information in for that one. So I'm starting there, this time with £120. So I've got 120. I've got to divide by 50, and dividing by 50 will give me 24. You can do that a little bit more slowly if you need to. Then 24 times that by the 80. 24 times the 80 gets me to 192. So I've worked out there that he will get 192 euros. The second bit of the question is he had 60 euros left when he returned. How many pounds was that, it should say. How many pounds was that? So I'm going to use this but working backwards. So I'm starting off here with 60 euros. So my 60 euros, I've now got to do the opposite. I've got to divide by 80. And 60 divided by 80, or 60 euros divided by 8, there will give me £7.50. I've now got to times that by the 50, working backwards again, and that times 50 will give me £37.50. The crucial bit is what we call going through 1, setting it up to get from 50 to 1, 1 to 80. 50 to 1, we divide by 50, 1 to 80, we times 80. And whatever numbers you're given at the start, you can always put a 1 in between, and you'll always be able to get there. Okay, moving on to a different subject area now. We're now going into algebra, simplifying algebra. So, first question. What is f plus f plus f plus f plus f? There's 1, 2, 3, 4, 5. If they were frogs, you'd have 5 frogs. 5f. Question answered. Q times q times q times q. That's q times by itself 4 times, so it's q to the power 4. Next bit, expand 3 brackets y plus 5. That's going to be 3 times your y is 3y. 3 times 5 is 15. 3y plus 15. Factorize 7x plus 21. What is common to both of the 7 and the 21? We're looking at that actually. 7's in both. So I can put a 7 outside the bracket. X plus what times 21? Sorry, what times 7 gives me 21? The answer is 3. So it's 7 brackets x plus 3. Okay, moving over here to the indice questions. X to the 0. They always like this. Anything at all to the power 0 is 1. Really simple question. Worth 1 mark, but if we just learn that now, anything x, y, p, q, 7, anything at all to the power 0 is 1. You've remembered it. Simplify this one. You do the numbers first. So 2 times the 3 is 6. P to the 4 times by P to the 5. For multiplying, we add the indices. 4 add 5 is 9. 6p to the power 9. Another question here. 12a cubed b squared divided by 6ab. Do the number first. 12 divided by 6, 2. A cubed divided by a. When we're dividing, we subtract the indices. And here, don't forget that a is just a to the power 1. So 3 take 1 is 2, a squared. And then 2 take 2 is 0. So we've got b to the 0, and we know that's 1, because anything to 0 is 1, so it's just 1, but we're already timesing anyway, so there is no b. That's your answer. This is to the power question. That's x squared, all cubed. So it's x squared times x squared times x squared. When we do that, we add the powers. 2 add 2 is 4, add 2 is 6, equals x to the power 6. We could have just done 2 times 3 is 6. When it's a power question with indices, we multiply the indices. Solving equations. I've got some simple ones here to do. I'm going to start, and of course we're going to use the flow diagram method. So 2x plus 3 equals 16. X times the 2, add 3, gives us 16. To undo that, we come backwards. Opposite of add 3 is subtract 3. Then we will divide by 2. 16 take 3 is 13. 13 divided by 2 is 6.5, or if you want, 6.5. And that's what x equals. I put this one in here slightly differently just to make sure you know what that means. That means x divided by 3 equals 7. So x divide 3 gives you 7. Working backwards, 7. Opposite of divide by 3 is times 3, which is 21. So x equals 21. Check that. 21 divided by 3 is 7. Okay, with the unknown on both sides, we've got x on both sides here. The first thing we do there is just cancel them down. So I can take 2 x's from there to leave them with no x's, but then I must take 2 from there. End up with 2, and it's a positive 2, equals x plus 3. We could use a flow diagram. What do we add to x? Sorry, x add 3 gives us 2. What must x be? I will do the flow diagram there because we've got a negative. So it's x, add the 3, gives us 2. So 2, subtract the 3, will give us minus 1. So it should work for x equals minus 1. That would be minus 2, add 2 is 0. Minus 3, add 3 is also 0. Inequalities. List the integers that satisfy this inequality here. Now, the crucial bit here that you may be struggling with is forgetting what that word integers means. And of course, integer there just means a whole number. And a whole number is going to be fairly simple to look at. Which whole numbers are between minus 2 and 4? We can have minus 2, minus 1, put the pen to work, minus 2, minus 1, 0, 1, 2, 3, 4. Just going to go and check that. That's all my integers, all the whole number between these two numbers here. However, that sign there is saying I've got to be bigger than minus 2, so I can't actually have minus 2, so I'm going to cross that one out. At this end, I can be equal to 4, so I want it on there. Represent y is greater than or equal to minus 1, but less than 3 on a number line. Same sort of idea. I'm going to put a circle at minus 1 there, and a circle at 3, and I can be anywhere between those, so I link them up. And now for the final bit. Can I actually stand at minus 1? Can I be there? Yes, y can be equal to minus 1, so I colour it in. Can I be there? No, it's got to be less than 3, so I can't actually stand on 3, so I leave it as it is. Solving an inequality is here. This is very simple. We do it just as if it was an equation. Write it like that, and we just did this one, I think. X times 2 minus 3 gave us 16, so 16, add the 3, divide by 2, actually it's not the same, it's slightly different. 16 add 3 is 19, 19 divided by 2 is 9.5. So no, x would be equal to 9.5 if it was a question. So I could write here x equals 9.5. However, it wasn't an equal sign, it was that sign. So I just rewrite it exactly the same, but x, and copy that sign, 9.5. I write it over here to be clear, x, copy the sign, 9.5. Question done. That could be worth up to 3 points for basically solving an equation and changing the sign at the end. The nth term. This comes up quite frequently. Work out how many there would be in the 50th pattern. You'll quite often get a pattern of houses drawn out for you, something like this maybe, or something else with matchsticks, and you need to draw various different patterns of them. Work out how many there would be in the 50th pattern is a common question, or explain how Raj could work out how many were in the 80th pattern. There are all ways you can do that. The simplest one though is to find the nth term and use that. So find the nth term. What is this going up in? That's going up in 4s, 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 and 4s. So it must be the 4 times table. So it's 4n. We've just shifted the 4 times table up. The 4 times table will be 4, 8, 12. It's gone up by 2, so it's 4n plus 2. So when you come to work out how many there will be in the 50th pattern, you do 4n plus 2. I don't know why I wrote 12 there. I'll just undo all of that a minute. Sorry. 4n plus 2. So when you have the 50th pattern, you will do 4 times 50 plus 2, which would be 200, plus 2, which is 202. Explain how Raj could work out how many in the 80th pattern. If that was the question, you could write he could use 4n plus 2 and 80 for n. So 4 times 80 plus the 2, 4 eighths are 32, so it'll be 320 plus the 2, 322. Okay, Pythagoras. This is a big pointer. It's every year it's on the exam. You can only use it in right angle triangles, and just be careful because you might get asked for the area rather than just a straightforward length of one side. Okay, we'll look at this question here first of all. Very simple one. It's just asking you to find x. So if I was doing this, I would very simply and quite quickly draw on the square there, draw on the square there, and draw on the square there. And don't forget, you should be remembering this from your revision poster. This little one with the plus, minus, minus. Put the right angle in there. Plus, minus, minus. So I'm getting the big side, so I want a plus. So I write 4 squared, 16. 3 squared is 9. So this is going to be 16 plus the 9, which equals 25. So the square is going to be 25. You must write that calculation out. That's where you get your method mark from. If the square is 25, you've got to do the square root of 25, which is 5 on the edge there. Okay, finding the area of this triangle here is slightly different. To find the area, I need to do the base times the height. I haven't been given the height. I have got the hypotenuse here though. So again, this is looking like a Pythagoras question. I'm going to draw on something resembling some squares there. So to find the area first of all of this big one, it's going to be 13 squared, which is 169. That's a square number you need to learn. 14 squared is 196. 12 squared is 144. So I found the 2 squares. Looking back here at this diagram here, I'm finding this one, it's a minus 1. So it's going to be 169 minus 144, which equals 25. So I know the square of this side is 25, so h here must be 5. The question was though, find the area. Now if I'm finding the area, I'm going to have to do base times height and then halve it. So 12 times 5. 12 times 5 is 60. And then I've got to do 60 divided by 2 equals 30. So the area would be 30. I've not put any units in here, but maybe it was 30 meters squared or centimeters squared. Don't forget to put your units in if they're given them to you in the question. Okay, double brackets. Now I've put kissing here because it's really important that there isn't any sign between these two brackets here. If it was take away or something, it'd be different, but it's when they're just touching here, and it means they're multiplied. So double brackets when they're kissing, I call that. We're going to draw our grid. So many people try to be quick and do this at the grid and end up getting it wrong. So take the time, draw your grid. Y times y, y squared. 3 times y, 3y, it's a plus 3y because it's positive 3. 4 times y, 4y, it's a negative. 4 times 3 is 12. A plus times a minus is a minus. Remember, good things, bad things. I'll rewrite that out now. I've got 1 mark already from a 3-mark question. Y squared plus 3y minus the 4y minus 12. I can simplify that to y squared. Well, 3y to take 4y is going to be a minus of y minus 12. If you can't do that last stage there, no panics. Get that one. The marks generally go 1 for that, 1 for that, and 1 for that. So that'd be 3 if you got that one there, right? Now this question. Again, I've put this in here because so many people get this wrong. They see that and they go, oh, simple. X squared, 7 times 7, plus 49. Totally wrong. Write it out as a double bracket. First of all, x plus 7 times by itself, x plus 7. So these are this kissing bracket thing again. As soon as you see that, you know you've got to put that into your double brackets as a grid. X squared, 7x, 7x, 49. X squared plus 7x plus 7x plus 49. X squared plus 14x plus 49. 3 points. Done. Lots of people make mistakes on that. That's 3 points that only about a quarter of the people doing the exam ever get. Make sure it's you that gets it. Okay, we're now on to the shape and space section of this revision video. Line symmetry, mirror symmetry, that's really quite straightforward. I'm sure that most of you are pretty good at that. Which of these can I draw a mirror line on? Mirror line there, one mirror line. That one, I can split there and there. The R, there's none. The I, right down the middle there, and one across there. The S, well, that wouldn't work because I have that missing bit over here, and it wouldn't work that way up either, so there's none on that one. Rotational symmetry seems to be the one that confuses people. It's how many times I can take a piece of tracing paper, pick it up, and put it back over the letter so it fits. Now on the C, even if I turn that all the way around and bring it back over, I won't be able to get it to match up because I've got the little gap bit just here. So C, there is only one way I can put that tracing paper back on the shape there so it matches. So we would say that has rotational symmetry, and there's one way I can put it down so it's order 1. The H is a different case because the H is like that. I can put it down back as it is, but I could also pick up the sheet of paper, tracing paper, spin it around, and it would also fit that way around as well. So that's got 2 ways of doing it. So the rotation order symmetry there is 2. Similarly, the S I can have as it was originally, or I can spin it around and do it that way. Likewise with the I. So both the S and the I would both be 2, whereas the R's only got one way I can possibly put the tracing paper down, so that would be 1. Hope that's clarified that for you. Okay, construction. Construct a triangle 5, 6, 7. In the exam, it'd be written a bit more lengthy than that, with a base 5 centimeters, sides 6 and 7. You basically need to get your compass. You draw one line 5 centimeters long. Then you get your compass and you draw an arc there with your compass. Spin it around and draw a nice arc. That distance there would need to be 6. Then from this point, you're going to need to do one that's longer. That would be 7. So I'll get a different colour and do a 7 one. A 7 one would be longer. That's your compass at 7. Where they cross, there will be where your triangle is. You then need to get your, just have to skip forward and skip back to get rid of that triangle. You then need to get your ruler and do a nice straight line between there and there and there and there. And I've constructed a triangle there. Okay, equidistant line or perpendicular bisector. This is the one where you're going to draw your rhombus. So first of all, you put your compass point at B and open it up to B rather than A, and you draw your 2 arcs, one from each point. You draw your 2 arcs from the same over there. You then get your ruler and you're going to join in all the lines you can, from there to there, from there to there, there to there, there to there, then join in that one and that one. Your equidistant line between the two is actually this line here, but you don't need to say that, that's absolutely fine, you've done the job. If you've got a line here where they're asking you to find the perpendicular bisector of a line, you just need to mark on, they may give you the 2 points at the end, they may call that point A and that point B or X and Y, or they may not. Whatever they do, you just put 2 marks on there, and again you do exactly the same as we just done. You draw your arc up there, like that, down there, and then this time, do it in black, you just join in to make that rhombus. If you can draw the rhombus, you've got the question sorted out. And as you can see, I've cut this line here in half, the bisect, and perpendicular, because that will always be, so perpendicular, it will always be at right angles. Last one, angle bisector. For this one, set your compass, draw an arc with the same distance from that point at the start here. Then you put your compass point there, draw an arc over here, arc over there, and then you start drawing them all up. And again, you end up with your rhombus, draw the diagonals in, and you've done it. Again, the bit you actually wanted was this bit here, but it didn't matter. You don't need to show the examiner that. They're just happy with it if you draw it without highlighting that line there, so you're all done. Okay. Area and perimeter count. This is one of the simple questions. The reason people get this wrong is they just have not learned what the word perimeter means and what the word area means. If you bother to learn those two, this is an absolutely easy question. Area is the amount of space inside a shape. Perimeter is the distance around the outside of the shape. I always like when I do this question to make sure I'm going to get it right by dotting it. Work out the perimeter of the shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 centimeters, because it's on a centimeter grid. Make sure you write the centimeters in. Work out the area of the shape. Might use a different colour pen here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 centimeters, and they're square, so centimeter squared. Could not be more easy, that question. This one is find the volume of the solid prism. Well, that's how many cubes you need to make it. We've got 1, 2, 3, 4, 5 there, and we've got 3 rows of it. Don't forget there's ones you can't actually see, but there would be 3 whole rows of it. 5 times 3 equals 15, and they're centimeter cubes, so you need that. Dead easy marks, those ones. Okay, parallel and perpendicular. You sometimes are asked to mark parallel lines and perpendicular lines. Parallel lines are any lines that are going in exactly the same direction. The old train tracks never meet type idea. Often we put arrows on to show they are. So those ones there, parallel. Parallel. Okay. The other ones you need to know are perpendicular. Now perpendicular lines just means they are at right angles. And I've drawn mine there to be at right angles. I'm absolutely sure that that there is a right angle. Just draw it in for you, so I know that is a right angle. They don't have to be formally on the grid. I could have drawn them that way round, wonky some people say. That's still, as long as they're right angles or 90 degrees between each other. Basically, if you had a book, can you pick that book up and fit it in the corner there? Does the corner of your book fit into there? Would be perpendicular. It's the posh name for right angles. Remember that word, the 2 P words. Okay, the big one, worth up to 8 marks sometimes. Terra, transformations. Let's remember it. We say terra, translate, enlarge, rotate, reflect, or you're resitting because you won't get those important 8 marks. Translate is a S for slide, enlarge is a G for grow, so when the shape gets bigger. Rotate is turn, reflect is flip. Where do the points come from? If you identify it as a flip, you must write the word reflect. No good writing flip, you won't get the marks. You then need to give the mirror line. For example, it might be x equals 4. There's 2 bits of information you must give, hence 2 marks. Rotate is the turn one, so you need to say rotate. If you say turn, you won't get the marks. Degrees and direction. anti-clockwise, 90 degrees, or 90 degrees clockwise, the double D, you need them both. Center of rotation, which is the point that you spin about. Where do you put your pencil? Where does it turn about? Normally given as a coordinate. 3 marks. Enlarge. Grow. Shape gets bigger. May also get smaller, but just think it's getting bigger. You need a scale factor, how many times bigger, and where the center of enlargement is. Where is it all growing from? If you get that, you've got your 3 marks. This center of enlargement is where you start your walk from. You may have a point and you're going to walk 2 up, 2 across, 3 up. If the scale factor was double, you'd walked 4 across, 6 up. That whole walking idea. Translate, that's just a simple slide. How far across you go, how far up you go. So you must write the word translate. If you write slide, you won't get the mark. X and Y must be as a column vector, not as 2 coordinates side by side. When it's a movement, it's vertical. X is how far you move in the X direction. Y is how far you move in the Y direction. If you're going that way, it's positive X. If you're moving that way, it's negative X. And likewise, if you're going up, it would be positive Y. If you're going down, it would be negative Y. Really important terror. Make sure you know it. Okay, 3D shapes, volume of prism and surface area. Very quickly, I put this in here because there's some key words. Vertices. Vertices is a posh word for corner. So write down the number of vertices. Write down means it's going to be easy. How many corners? 1, 2, 3, 4, 5, 6. 6. Remember, vertices is corners. The number of faces. Faces is the sides, if you like, or the bits you could touch. Is 1, 2, 3, 4, 5. I've got the 3 around here, and the 2 ends is 5. The number of edges, that's the bits that join the vertices. 1, 2, 3, 4, 5, 6, 7, 8, and that last one there would be 9. It sometimes helps in the exam if you actually draw over them. So I'll do that again for you. 1, 2, 3, 4, 5, 6, 7, 8, and 9. I've drawn over them there so you can be clear where you've got them. Okay, here's a cuboid. I asked you to find the volume. To find the volume, you find the surface area of one slice of it, and that's going to be 3 by 4 is 12, and then we've got 6 slices of 12, so it's 6 times 12 is 72 centimeters cubed. Don't forget the units. Okay, you may be asked to find the surface area. To do the surface area, we're going to have to do all the different bits. We've got the top, sorry, the 2 ends, that's 2 pieces. They're 3 by 4, 3 by 4. We've then got the big bit, that's the lid, which is going to be 4 by 6, 4 by 6, and the same for the base, 4 by 6. And we've got the 2 sides, which are by 6, 3, and also another one that's 3 by 6. Right on what each one is, 12, 12, 24, 24, 18, 18. To get the total volume, you just got to add up each of those. That would be your answer, and it would be in centimeters squared. Okay, circumference and area of a circle. Really important you learn these 2 formulas. Without these 2, you can't do it. Twinkle, twinkle, little star, circumference is 2 pi r. Though I know you do not care, area is pi r squared. Okay, you've got those 2, you better do it. Remember, the radius is just from the center to the edge. The diameter is all the way across, right across that circle. You may be told that, but you want to find the radius when we're doing these calculations. And of course, all the way across is from the edge to the middle, from the middle to the edge, which is double the radius. All you do for the circumference, you start with a radius, you times it by 2, you times it by pi, and out comes your circumference. If you've got a question where you're given a circumference, to find the radius, you can just undo that circumference, divided by pi, divided by 2. If it's finding the area, how much is covering, it's all the green area here. It would be the area is pi r squared. You remember that from your little song there. So the radius, just square it, times it by itself, that is. When you've got that, you times it by pi, that will give you your area. And likewise, you can undo that if you need to get from the area back to the radius. Really, just learn those formulas. Okay, we're on to the last bit. Data handling, stem and leaf. This is my favourite. This was the one that kicked all of this off, all the back of the net stuff off. It was all, order, and key. You all know that one. Remember, if you're doing a stem and leaf, you write that down right at the start before you even do the question. Then you get your final question. You check, have you done all the data? Yes, you count it. Have you put it in order? Yes. Have you given a key? Yes. Remember, key, like that, 21 is, sorry, did that wrong. 21 is 2 stroke 1, etc. Must always put your key in. So many people miss that last mark. Okay, questionnaire design. This is all about someone writing a questionnaire. How did they get on? We use time to remember this. And time stands for time limited. O stands for the overlap. W stands for where, sometimes who, even when. And N is none. Okay, and how do we use that? Very often we'll be given the question and it will ask you to state 2 things that are wrong with the question. You've got to look down your list and pick off something that's wrong with the question. It might be, how many sweets do you eat? And the question should have been, how many sweets do you eat in a week? There's no time limit to it, so look for the time limit. Look for the overlap. Are the boxes overlapping? Look for, there isn't a chance to say, I don't actually like sweets at all, so I ate none. And finally, where you're asking, who you're asking, when you're asking. If you're asking a survey about sweets stood outside a sweet shop, it's probably biased, not a good place to ask it. Where should you be asking it? Yes, that's right, in the town centre. That's why we remember town. Where should you ask a survey? In the town centre. Doesn't matter what it's about, you always answer in the town centre. Remember the town centre, time limited, overlap, where, none. Job done. Okay, averages and range. Just got to remember what these key 4 words mean. The mode is the most often. Really easy because it begins mo. The median is the middle. Make sure you've put them in order. Very important. To find the median, it's got a D in the middle. Middle's got a D in the middle. Couldn't be easy. The mean. I just think that's the nasty one. You've got to add them all up and then you've got that tricky division at the end. The range is the highest. Subtract the lowest. Now in science you might write 90 minus 23, for example. In maths you've actually got to work out what it is and say that 90 minus 23 equals 67. If you don't do that last stage, you won't get the mark. Okay, mean from a group table. This comes up every single year. You must be able to do it. It's quite a long thing. We make it simple by remembering TAD. Times, add, divide. The questions here is some information in time and the frequency, and you've been asked to estimate a mean. Because it's estimate, you know you're going to have to write these bits here. What I've actually done for you is do that question, all the workings for that, quickly beforehand, so I can now just take you through the whole TAD thing. The first thing I've done is find the midpoint of each group, and I've written it over the middle there. No adding it in an extra column, just write it straight over there. Then I've done my times, the first bit, times. 3 times 15, 45. 9 times 25, and so on for each of those. So that's my times. I've then got to do my add. The first add is adding up the times that I've just done. There it is. The second add is going to be adding up the frequency. There it goes. It's 80. It was easy this time. They actually told me in a question it was going to be 80. I did it to check, but it's there, 80. Then my add. The last thing I want to be doing is the divide. There's my divide. Got it there, 1038 divided by 80. Some of you get confused, is it 80 divided by 1038 or 1038 divided by 80? Doesn't matter, give it a go and see. The average here is going to have to be round about the middle, so somewhere between 12 and 18 probably. I did it this way round and I came out with 12.97. I reckon that's right. That's my mark's done. Okay, scattered diagrams. I think this is the last one. Check what the units are going up in. It's going up in ones here, so each little square would be 0.1. This one's going up in tens, so each square is 1. So square there, sorry, get a different colour pen. A square on this axis is 1, and a square little square on this axis is 0.1, just so I don't make a mistake. In January this year, the rainfall was 6.1, sold 32 umbrellas. You're going to have to put a point. You can do that. Just make sure you get your two scales right. What type of correlation does it show? Positive. Don't worry, if it was going down that way, it'd be negative, but it's going up, so it's positive. What type of correlation? I've done that. In February this year, Mr. Withers sold 40 umbrellas. Estimate the rainfall for February. This is why I included this question. You must, when you're doing your estimate, first of all, draw your sausage around the data. Then, draw your line through either end. Now I've got my line of best fit drawn. If you don't draw a line of best fit, you won't get any marks. The next stage for me is to read off the information, estimate the rainfall for February. For February, hold on, I've got this right. What type of coloration does it got to show? In February this year, so 40 umbrellas. So I need to look at umbrellas. 40 is there. Draw a line across to my line. There it is. And then I've got to draw a line down from my line and read off there what it is. Now I know they're going up in 0.1s, so that's going to be 7 point, I've got 4 squares, 7.4, so I can quite confidently write 7.4 in there. I should have put centimetres, shouldn't I, actually, to get the full mark. Okay, that's been quite a long video, but I do hope it's helpful. Now, just a last little few words of help and advice before the actual exam. Make sure you've been to the loo. Check your phone's not on you and somewhere safe. Sounds a bit daft, but if you've got something to put on if you're cold in the exam, you've got an extra layer you can put on if you get a bit cold. If you get too hot, can you take a layer off? Have you got enough pens and pencils, etc.? Before you go in an exam, copy out the tracing paper thing, that poster. Make sure you can do it. Get it fresh back in your brain. If you've got your own poster going, got your own one with your own tips as well, make sure you've got that one. When you're queuing up to go in the exam, or when you're waiting for lunchtime before the exam, be reading through your own revision notes with the little cards you can get from the website, or listen to your MP3s as well. Try to avoid chatting and panicking about what it is you haven't learnt yet. It's not going to help you now. All you can do is go in with what you know. If you have got your notes in your back pocket and you're using them, don't forget, chuck them in a bin as you go in, or give them to your teacher to look after, or leave them outside somewhere safe from the room. Okay, when you get in the exam, first of all, check you are comfortable. Make sure the table's not rocking. Make sure the chair's not wobbling. If it's not, it's okay to ask to change them. Don't sit there for 3.5 hours being uncomfortable. Get it sorted before we start the exam. Once the examiner has said start, copy the poster or your posters onto the tracing paper. Don't panic about how long it takes. Do it calmly and slowly. They'll be invaluable during the exam to you. The 3 or 4 minutes it takes is very worthwhile and worth investing in. Lots of you will also write your times table on another sheet of tracing paper. Again, it takes 3 or 4 minutes, but it's well worth it. It speeds you up so much more and makes you more confident as you go through the exam. As you're doing the exam, remember, probability is always right as a fraction unless it's obvious it's a decimal. Never, never, ever write 1 in 4 or 1 in 6 or 1 to 6. Always 1/4, 1/6, or maybe 0.25, 0.5. When you're asked to round an answer, round it. But first of all, give the original answer so you can show that you got your calculation right, and then they'll be marking the rounding. Check every answer as you complete each question. That's really important. When you get to the end of the paper and you've done everything, go back and check every question again. And finally, check you've done every page by counting the page numbers. So actually look at the page numbers and count them as you go through. If a page has got stuck together, you may notice that. In quite a few exams, I've seen people have the centre page stuck together and they don't actually do it until 2 minutes before the exam, when the end of the exam, when they realise they've missed the whole page out. Also, the back cover. So many people forget to do the back cover. I've just noticed there I've got a bit of a spelling mistake. That should be including. I'll put it in there for you. The back cover. Okay, and in the exam, let's remember our sucks as we go through it. It'd be sucks if you've got to do it all again, so get it right this time. Simplify all your answers. Put units in all your answers. Check all your answers twice as you do it, and then when you're finished again. Keep all your work in. Don't scribble it out. Leave it there. The examiner may see something and give you a mark for, which you can give you a mark for. And also, stay calm. Do what you can do first. Don't get panicked by the stuff you can't do. Work calmly through the stuff you can. I hope that's been helpful to you. It's a long video. Above all, remember, keep calm. Focus on your goal, and most of all, put your ball in the back of the net. Good luck to you all.